Welcome back, everybody. We're going to be working on the module 3, labs 3 and 4 in this video. And we're going to move on from the topics that we were talking about in the previous video, which was while loops. And we're going to look at the other looping structure in the Python language called the for loop. Start by doing a little reading first. So I'm over at W3 Schools, and and I apologize if this is way too big on your screen, but some people use little screens when they look at this stuff, so that's why I'm zoomed in. It also helps to get rid of the ads that are on the side. But like a while loop, a for loop is also used to repeat code, but for loops really kind of have a special place in programming because a lot of programmers really kind of prefer them as their go-to loop for a number of reasons, especially when the number of iterations or repeats of the code is either finite, like predetermined, or dictated by the size of the data structure that you're traversing. So for loops are often very, very useful in traversing, structured data. So this thing that you see here, like a list or a tuple, a dictionary, a set, or a string, are all what we call like ordered pieces of information that contain multiple values. And so like if you had a data component or whatever that had multiple values inside of it, you want to traverse each value, the for loop is particularly useful. Um, Yeah. Now, this is actually kind of an interesting statement I'm seeing up on the screen here. And they say this is less like the for keyword in other programming languages and works more like an iterator method found in other languages. So what they're trying to tell you is that the for loop in Python is more like a for each loop in like Java, for example, where a for each, you might traverse a file and it just automatically traverses it without needing to know its size or length or structure so much. I will show you how it operates here in just a second. But with the for loop, it says we execute a set of statements once for each time in a list, tuple, set, etc. Right? So they're really kind of focusing on this concept of lists. Now, we are going to look at list as a concept here in just a little bit, but just as a real quick preliminary, they have an example of one on the screen here. And so basically, really what a list is where you create, a spot in memory. You can save it in a single variable name, like we see here, like a normal variable. And then we take the multiple values and kind of define them with a set of square brackets, right? And then all the values inside the list are separated by commas. Now, whether this is a list of strings, but it could be a list of integers or floating point values or other complicated structures, objects, other lists, etc. But this is a real basic one. It's a list of fruit, right? So we put it in a variable structure called fruits. We call that a list. And then the for loop here, we say for X and fruits, and X becomes kind of a variable name of our choice, but often it makes sense to call it what it is. So you know what, I'll go into the try it thing and show you what I mean. So fruits is a combination of fruits. So often, like programmers might do stuff like this for fruit in fruits. So like each individual one is a fruit, and then, we're traversing. I'll leave it as X, but I'm just kind of making that point right now. Now, if I was to make this list bigger and add like an orange to it, for example, and run it, you can see the for loop will automatically traverse the structure. So for every thing inside that list, that's the X, right? Every individual thing inside that more complicated structure, every time we run the loop, we'll put it on the screen with a print statement. Notice I don't have to increment, right? It automatically traverses the structure. There's no true false here. It just runs over the length of the structure and just works, right? So you can see why programmers like this, right? Because if you're working with structured data or information, the for loop is a real logical one to use. Right? It's not the only way to do it, but yeah, it says here, that doesn't require an indexing variable to be set beforehand. So no wonder programmers like it, because then you don't have to forget that piece and then get stuck in an infinite loop and then break out of it. So interestingly, we think of that list structure that I just showed you, but for loops also have the capability of looping through strings, right? So because a string in truth is really a collection of individual characters, right? And so what this loop would do is it would go character by character through the string structure and then print each one. So there you go. Real exciting stuff, but powerful, right? So that means I can take any string and process it with a for loop, either character by character, or word by word, or whatever. So very, very useful in language processing. Uh, like the while statement, we can put breaks in. So for example, we go back to our fruit list and we start traversing that. We can also drop in other code. So it doesn't have to, just be output, obviously. So I can put in an if statement and I can say, if we reach banana, break out of the loop, right? So watch the output of that. So we hit banana, it printed it, right? Because the print happens before, and then we're out of the loop. Cherry never gets printed. So break statements work as well. All right. So now they're doing the same thing, and right, and you can see I was kind of like talking us into this too, right? The banana printed because it happened before, but if we put the print after, banana never even prints, right? All right. So that's just the logic thing and how you choose to operate. It also has a continue statement. So if we reach that code, I'm not going to demo this one, but I think you get the concept. If we hit banana, it's just going to continue, and you don't really need to kind of see that. That's just going to run. The continue thing is something that can be useful, right? Like, so you hit a certain thing of code, um, and you find reasons to kind of still move on with your loop, but maybe omit like one thing. And we saw that with the while loops in the previous video. Right. Often when we're using for loops, sometimes we use a related function which helps us control kind of like a start and end point of how many times we're running it. And they call this the range function. And basically what it does is it returns a sequence of numbers. By default, it starts at 0, right? So if you don't declare 0 as the starting value, and then it increments by 1 by default, but you can actually control that. And basically what it does is it ends at a different number. So really usually the range command will have a starting and an ending value. If there isn't a starting value, if you still only see one value, it's 0. You're starting at 0. Um, you're incrementing by 1 each time, but if you want to increment, let's say by 2, then you add a third parameter to it. I'll show you that in just a second. But here it is for x in range of 6, right? So the example is we start at 0, we go up to 6, and we run the loop. Now I'm going to alter this and just show you. Well, actually, let's start with 1 this time. Like if you use the 2 parameter method, and I think this is more common, and even people that want to start at 0 usually include it here as a parameter. But this one allows me to start from 1 and go to 6. Now, I don't know if you guys are catching this or not. Do you notice that it doesn't reach 6? Yeah, it never reaches it. Even so, here, let me go back to this approach. And this is actually very much by design. So, okay, so in 0, 1, 2, 3, 4, 5, which is 6 values, but it never actually reaches the number 6, right? And this is a thing. So if you want to print the numbers 1 to 10, for example, right? I do 1 comma 10, I have to put 11 in the second position because it never reaches that top end of the range, right? So when you put something in the range command, you're always going 1 beyond whatever uh, the top thing you want. So if I want to reach 10, I set this to 11. Right? There's a reason for this, right? But just kind of looking at this, right? So the two parameter approach. And then you can also add a third parameter. And since I already have this on the screen, I can count from 1 to 10. The third parameter would tell me what I'm counting by. So I could count by twos, for example, right? So I skip a number. So I go 1, 3, 5, 7, 9, right? And you know, if I'm adding 2 to 9, it gets to 11, but we never hit 11, right? You can also flip these, by the way. So I could go from, let's say, 10 to 0 and go the opposite direction, in which case I would do a -1. Watch the output on that. Right? So this just goes backwards. So you can count up or count down, right? It has all of those capabilities. Now, the range command is powerful because we are basically controlling our loop mechanically, right? So instead of like traversing a predetermined structure, here we're running a loop with very particular control over it. So, you know, similar, maybe a little more similar to a while loop in that regard, but this is where I think when you use the range command that it becomes a little bit more like for loops in other languages, right? When you add in the range. But kind of a unique little feature. Like the while loop, the for can have an else. So like after the loop completes, you can output something if you wish. Right. But it says the else block, and this is pretty important, will not be executed if the loop is stopped by a break, because technically the else is part of the loop, right? Here's an example to break the loop when X is seen, see what happens with the else block, right? So if we run this, it gets to 3 and it drops out and never prints that. If I eliminate the break, in fact, if we just eliminate this, right, and run it, we'll see what the else does. It will just iterate and then get that message. It's similar to the while loop, right? Once again, I don't see a lot of people using that else, you know, in while loops or for loops, because it's kind of the equivalent of placing a statement after the loop and it just runs anyhow. So that would be my go-to, but I'm just, you know, teaching it. So it is possible. And this is where it kind of gets to be a little bit of a mind bender for people when they're brand new to coding, that you can take a loop and place another loop inside of it, and we call this a nested loop, like an if statement inside of an if statement. We call those nested ifs. A loop inside a loop is called a nested loop. And then notice what it says here. It says the inner loop will be executed one time for each iteration of the outer loop. So if I have a loop, an outer, you know, the outer loop would be the higher level one. So for every time that runs, the inner loop will run all of its iterations. So for example, if the outer loop is going to traverse this list, right, then the inner loop will traverse this whole list each time it runs this. So for example, we would do red and then apple, banana, cherry. And we do big apple, banana, cherry, tasty apple, banana, cherry, right? And what's interesting about this example, right? And they show you kind of the output here, because inside the inner loop, they're printing both to show you where you're sitting inside the inner and outer loop. So outer loop is all reds here, but we traverse all the inner loop stuff. The outer loop is all bigs here, right? Traverse all the inner loop stuff, etc. Right? Um, kind of interesting, right? And you know what? If your question in your brain is, could I put another loop inside the inner loop? Sure. In fact, you can take it as deep as you want to go with it, as long as your brain can conceptualize what's going on, right? And really, when you look at what we're doing here, is we're really kind of taking two lists and kind of turning them into a table or a matrix, right? You know, so like if I have two levels of loops here, I'm creating a two-dimensional table. and yes, the dimensions can go much deeper, but then it becomes very hard to visualize them both mentally and visually. Um, but very common to traverse, tabular data or table data with loops like this or multiple things. There is also this thing called the pass statement. And this is kind of a weird little feature, but sometimes you're writing loops and you want to write a loop, but you don't have the code yet. And you have all the other code written and you keep getting errors because you don't have anything inside your loop. If you know that you're going to put something in there eventually, you can just put in the pass statement that basically says, okay, well, I'm going to put stuff in here later. So for right now, just pass, so your code doesn't break. So your code, basically lets you run. Right. So that's all the background on the for loops. And they do have an additional thing here on the range, right? And I think we talked about it well enough here, but if you want to really read up on it more, there you go. It's a very short page. The other piece of information is talking about the lists. So let's go here and take a look at lists. Now, for anybody who's coded in a different language, when you look at this, because we use similar structures in other languages, most of you, and the first time I encountered Python, I'm like, oh my God, it's just an array, right? This is an array, isn't it? And it is, right? So in Python, we call it a list. In most other languages, especially when we use the square brackets, we call it an array, right? So if you ever hear me interchangeably using those words, if I'm talking about an array in Python, I really mean a list. Okay. However, not to confuse things, but if you looked at a language like any of the C languages, really, like Java or C# or C++ or whatever, they also have array-like structures that are called lists and use angle brackets. So that would be like the shift of the comma and period keys. Those are angle brackets to do some of the syntax in those. So not to confuse things, but it just really has to do with their functionality in those other environments. So here, array structures are basically called a list. Now, what's interesting about these, right, lists, and I don't want to go like super deep into this, but I'm going to pull up Excel here for just a second. And this is actually kind of a standard thing I kind of do when I'm teaching this for the first time. And I'm going to make this as simple as I can here, but I'm going to do a little bit of drawing. Basically, I'm using Excel because it's just the fastest way for me, or at least my brain, to do this. So basically, you can think of a list as one named structure, right, that holds multiple values. See, I'm having a hard time typing and talking at the same time. So, the row with the numbers is the index for the list. And then the values for the list would be here. So if I could, like, for example, have like apple or, banana, etc. And just for the sake of simplicity here, I probably really shouldn't use the same fruits. I'll just take the time to actually type out fruit names. It's so challenging. And pear, that's a good one. There we go. So this is a list that contains strings. And what's interesting about a list is it is one named structure that holds multiple values. And then the question becomes, how do I access the individual values in the string if I need to? Well, a for loop can traverse the whole structure automatically, but if I want to single out the particular one, I have to use the index value to find it. And the index values in lists always begin with 0, right? Why? Because the base 10 number system has 10 basic values, 0 through 9, right? When we learn as kids how to count, we start counting, well, you don't want to count 0 because you don't have a finger for that. So you count 1 through 10. But really, when you get to 10, it's a double-digit number, right? Okay, so this is also part of the reason why the range command goes one beyond, by the way, which is why I'm kind of focusing on it a little bit. Because really, the length of this, you know, so if I said, length, there's a function called length of my list, it would return 5. That would be the result of it, right? If I wanted to find melon, I would say, so in other words, my list, and then notice the syntax here using square brackets in position 2, which is the third position, equals melon. And I'm doing this in Excel for a reason, because you can kind of visualize the data structure better that way. So this is the actual data contained. These are the index values, right? So you can find this stuff, and this is the name for the whole structure. Right? So that's kind of how a list functions in memory. And for me, it always helped, that visual always helped me to go, oh, okay, I get it. But the starting with 0 thing is kind of important. All right, so now as we read this, it'll make more sense, I think. So lists are used to store multiple items in a single variable, right? Lists are one of 4 built-in data types that Python uses to store collections of data. The other 3 are tuple, set, and dictionary. All of them have different purposes and usages. We're doing just a really brief introduction here to lists because it's the most fundamental of all of them. We use square brackets to create the list. So you give it a name, square brackets, separate the contents with commas, right? Numbers, strings, or more complicated objects. And then, if you ever do a print command on a list, by simply dropping the variable name in a print thing, it will print it out and show you its structure, including the square brackets, so you can see, hey, it's a list. So this is actually very useful if you're processing data, you don't know what the data is, but you want to see it. You just do a print command, drop the list name, and there, boom, it's on the screen. So very helpful. All right, it says list items are ordered, right? So we saw the indexing system. They're changeable, so I can take my list here, for example, and if I wanted to remove the pear and add in a dragon fruit or something weird like that, I could do it, right? Or I don't know, a grape is better fit here. So I can change the value. The other thing that they're about to mention is that I can have duplicate values. So I can have 2 of them holding grape. They don't have to be unique, right? They're indexed. The first item index is 0. The second one is 1, etc. But notice that when you look at that structure, that the length of the list is 1 more than the index value of the highest one. So I kind of see like the correlation to the range thing, it starts to make a little sense that way. Right, so lists are ordered. It means that they have a defined order, and that order will not change. So if you put something in position 0, it's going to stay in position 0. If you put it in position 5, it stays in position 5. If you add another item to the list, it's placed at the end. So in other words, if I added position 5 and put my I don't know, another banana in here, we're adding it to the end. I can't go lower than 0 for index value. There are also some list methods that can change the order, and we're not ready for that yet. But generally, the order doesn't change, right? So there are commands that can sort it and whatever. All right. So when we say the list is changeable, that means any of the content can be added, removed, or changed after the fact, right? So I think I've kind of demonstrated that already. But let's just say, hey, I added banana in position 5. Now I want that position gone. I can just get rid of it. No big deal. Duplicates are allowed. Why? Because if I have 2 of the same thing in the list, well, this is great, but it's position 2 grape. This is great, but that's position 4 grape, right? So they have their own index number, so that's why I can have duplicates. All right. Right. We have the length function, and I was kind of showing that a little bit. So sometimes, before you run a snippet of code, you want to know how long the list is. Like you want to determine what the length of it is, so you can run the range command correctly. So often we'll run the length function to determine the length and then use that to help us run our loops or whatever. Or like if you had a list that had like a bunch of people's names in it, you don't know how many names you have, you just run the length function and then it goes, oh, you got 500. You would know. All right. So you can put in basically any type of information inside of a list. And this gets a little mind-boggling. They're using three examples here. So they have one example of a string, one example of ints. Yes, you can put floats in there too. So if you have floating point numbers, but you can also do booleans. And if you really want to take it farther, and this is where it gets strange and very unlike other languages, you can mix data types, and that's kind of like an, oh my god, why would you do that? Although if you, like, for example, have learned how to code in Java or C Sharp or one of the other languages that we teach, usually you have a list and you say, well, it's full of integers, and you want to put a floating point number or a string in there. Too bad, too sad. You just can't, right? It just does not allow it because those languages are strongly typed in their array structures. Python, because of its extreme flexibility, we don't like put a indicator of what the variable name is in terms of a data type. I'm not calling it an integer data type. So it doesn't care what you put in there. It's like, oh, it's just a spot in memory. You want to put a string in? Fine. You want to put a number in? Fine. You want to put a complicated object inside of it? Fine. You want to put a list inside your list? Yeah, you can do that too. Right. And oh my God, it becomes really kind of strange. So I don't want to go super deep on this, but you can see this topic goes on and on and on. It says really lists are objects in Python's mind. So we haven't learned about objects and classes yet. And we also have what we call the constructor function. We're not going to really worry about this right now, but sometimes instead of creating something with square brackets right off the bat, you take information that you have and pass it in as a parameter, and then it creates a list. This is later stuff. And then we can get into much more deeper topics here, because lists then lead to tuples, which are almost identical to lists, different syntax, but they have one key thing: they're unchangeable. Really useful for data processing, though, where you want to not pollute your data as you're processing it. Then you have a set, which is unordered and unchangeable, sort of, and unindexed with no duplicates. And then a dictionary, which is ordered and changeable, no duplicate members, and it's set up with key value pairs. But these are higher level topics that we'll get to. Right now, we're just looking at lists on a basic level, so we can just do some stuff. All right. Let's get back over to the module. I think that's enough on lists for now. And I'm sorry if that kind of makes your brain spin a little bit, but that's kind of where programming moves to, right? So because Python is so heavily on, like, data processing, data science, artificial intelligence and stuff, those data structures are really important. And for loops are, often matched up with that functionality to be able to traverse the structures and do things with them. All right, let's look at our tasks here. So here's the tasks. Create a function called loop letters. The function should have one parameter for a string, loop through the string, and print each letter. All right, let's do that. Let's do some basics here. So back over to Visual Studio Code. I'm going to create a new file here, and this will be mod3 lab3.py. Just a little bit of preliminary info, just kind of like we did with the while loops. So we use the for keyword. This is just to reinforce here. A variable name, whatever you want, that represents the current iteration's value. So like whatever your construct is, with the while loops, we were looking at I. You could use that here too. But often you name the variable name or the loop control variable relative to what you're about to do. So if I'm traversing the letters of a name or a string, it makes sense to call my loop control variable letter, for example. Um, we use the in keyword, which shows that we're traversing individual components inside of a complicated structure. Um, or you think of that complicated structure as a collection or a sequence that we're looking at, or and maybe you could even call it a data structure. You want to use some higher level terminology. And then we have the colon to go into the body of it. Once again, for loops must be indented. That's kind of the repeat of the concepts once again. All right. Got the instructions again already, right? So create a function called loop. The function should have one parameter for a string, loop through the string and print each letter. Okay. But you know what? Let's kind of take it down to maybe something more basic here. So before I create the function, can we just practice a little bit? So how about for each letter in, what's my favorite phrase to use here? Whatever, we can print the letter. Just to kind of reinforce the concepts above, right? So this is our complicated data structure, which in really a string is a list of individual characters, right? That's why we can traverse it. And yeah, all letters have positions. This is position 0, position 1, position 2, etc. And then this is our loop control variable, right? So if you run this, let's see, it traversed whatever one line at a time. Isn't that exciting? So that's just kind of the function of it. All right, so that's going to happen each time now, but whatever. Let's go ahead and define that function. So we're going to define the function as loop letters. We're going to pass a phrase into it, some sort of string. You can call it string, whatever. It doesn't matter what you call it, right? So as long as it makes sense to you as to what it is. And then for, let's call it X in phrase, we will print X. Kind of what we already did, right? But now we need to call it because the function doesn't run unless you call it. And let's call it loop. I call it letter. We were supposed to call it letters. All right, so loop letters. We'll pass into it some sort of a phrase, and we could say, hey, this really doesn't matter much, but it is kind of fun. Maybe it's not, whatever. All right, but see how this is a much longer, more complicated structure. And yeah, it's going to print out like this, each character on the line. So it's kind of fun to watch it fly by. Let's go ahead and run it. So we had the whatever, right? And then it went to the new string, which starts here. Hey, and notice how it even prints the spaces. Really doesn't matter much with the commas, the spaces, and all of it. Right? So all of it, every little bit of everything inside those double quotes is treated as an individual spot in the list, basically, is really what it is. So a string is really a list of characters. So we're looping through the letters. And you know what, just to make this clear that we're done with this part of it, I'm going to just do a print statement with like a dotted line. So it just makes it easier to look at it. And then I'll do a new line character in there. So the next time we run this, we have like a little marker to know what we're looking at. And in fact, maybe that's a good way to separate all of these. So, we did that first loop to try it. It was just a test. And then we did the second little thing also just to test. Well, actually, it's part of the assignment, part of the lab, right? To try to make it work. And let's go to the next one now. So this one we're going to call, let's see what it's going to call. Create a function called loop numbers. The function should have two parameters for start and end integers. Loop through the range of numbers and print each number. All right, let's go ahead and do that. So we'll define a function and we'll call it loop. It's going to have a start and end, right? Sounds like a range, doesn't it? Yes, it is. And then here's the definition for it. So for each number in the range of start to end, we are going to go ahead and print that number. And I'm going to actually show you kind of a little trick here. You can also do this little command. I don't know if we've talked about this one. Where basically we're going to output the number, and instead of going to the next line, we're going to append it to the end of the string that we already have. And then when we're done with the function, I'm just going to put in a blank print command to go to the next line. So this will keep all the output on one line. We do have one issue here, though. If you remember how the range command works, so if I have a start and end of one, start at one and end at three, we know that it will never reach three. So I have to add one to the ending value in order to get it to reach three. Otherwise, it'll stop at two. Now we need to call the function back to the margin, and we'll say loop numbers, and then send in a start and an end value. So let's just do something really simple like 1, 10. All right, let's go ahead and run this. Here's the run. Right. So we can ignore everything above the dashed lines. That's why I put them in there. But here it is: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we're up. Okay. So if I wouldn't have had this in here, we would have stopped at 9. Right, so that's why that's helpful. All right, once again, I'm going to copy this dashed line thing so we can see the separator of the different parts of the exercise, and then we'll do the next portion. All right, let's see the last task. All right, so this one, we're going to loop through a list now and create a function called loop list, right? The function should accept a list, loop through the list and print each item, and then call the functions with appropriate arguments. Well, we've been doing that all along the way. So we just need to do one now called loop list, and we'll play with that a little bit. Let's go back to Visual Studio Code here. So let's create the function first. So we'll define the function called loop list. Well, if we're going to loop through a list, we need to send the list to it. So I'm going to pass into it some sort of a list. Now, what we're going to do here is for each item in the list, we will print the item. Now, we had some examples of lists, right? But just remember that you can create a basic list, and maybe I should type this in. You can create a basic list with a variable name and square brackets with each item being separated that's just kind of like the recall on it, if that's helpful. So you can, create your list and call it whatever you want. Maybe we can just use kind of like the fruits example, or maybe in my case, since I like to play guitar, I could call my list guitars and have square brackets. So my stuff's going to go inside of there. Now, by the way, I could create a blank list by just doing exactly what I did, right? Um, doesn't have anything inside of it. We're not really learning about lists here, but if you just wanted to create a blank one, that is the way to do it. So I'm going to just put in some guitar brand names here. So we could put in Fender, Gibson, etc. Right, and you can make this list as big as you want. I just want to have some items in there so we can traverse it. Now we need to process the list. Oops, and I didn't need to do that. So I'm going to go down to the next line here, and I'm just going to call it. So I'm going to say loop list by sending it my guitar list. So all of my guitars are in the list. All right, so let's go ahead and run this. Here's the run. All right, so there it is. Putting them back up on the screen. Pretty simple, really. Now, what's kind of fun about this is, yeah, you can create multiple lists and send them in there. You can even do goofy stuff like this. So I have one example here from my solution file where I'm mixing data types, right? And can it process that? Right, so I'm going to process the guitar list, and then I'm going to process this weird list, right? So there's two strings, an integer, a Boolean, and a floating point all inside there. Right, so here comes the run. You can see it does it just fine, doesn't care. Python is very weird that way. If I was to choose here to take this weird combined list and then throw my guitars into it, I could do that. So one of the positions in my list is a list. So let's see if this makes it break. No, it doesn't. It just outputs the list. Isn't that powerful? Just really, really crazy stuff here, folks. All right. So that is module 3, lab 3 in its entirety. We're now going to move on to lab number 4. So I'm hitting the next button here in Canvas. All right, so we're going to be working on this thing called the genre tracker. All right, so we have, once again, our background information here on while loops, for loops, and lists. We've looked at that pretty extensively already, but if you need to go back and refer, please do. All right. We are going to look at this documentation, though, because we need to look at some basic list methods. So like whenever you're dealing with data structures in Python, you will often discover that they have methods, which are really kind of what we call internal functions relative to certain data types and objects. And lists as a structure have this thing that we call append. And what happens with the append method is that it allows us to add something to the end of the string. So you can kind of recognize it as a function because it's got parentheses after it. So if I do this, right, now I append orange to the list of fruits, well, now fruits contains orange. So that's how I add stuff to a list. Very useful. Of course, there are commands to remove things, for example, and a lot of different things. So they have more examples, right? So for example, here they have one list. Here's another list. So I could take list A and append list B. So I could take that, but notice how it comes in. It comes in as a list in one spot. Well, maybe that's not the best way to do it, but the whole point is that you can do that. All right, so that's really enough of an underpinning here to actually do the work. So let's go back to Canvas then and look at our instructions. So here we're going to start to kind of mix things up a little bit. We're going to be using kind of a combination of all the techniques that we've been learning here today. So we're going to use functions, and we're going to use a while loop, and we might even throw in a for loop. So kind of all the things that we've learned so far. We'll have some if statements in here. A lot of techniques going to be demonstrated in this lab. All right. It says use a while loop to add genres to a list until we enter end. And maybe that's not really phrased all too well on that screen, is it? All right. So I apologize. That's what you get for copy pasting from other people. That's okay. But that's kind of what I mean, right? So use a while loop to add genres to a list until they enter the end command, right? All right. So that sounds like a thing. So let's look at the output on that. So please enter genres of music you like, type end to move on, right? So you might enter, so for example, you get a little menu here, you get a menu option, and then you would enter genre, country, ska, R&B, whatever, it is you like. And so let's keep reading on here. List out each genre, assigning each one to an incrementing number starting at 1. Okay. Choose a genre and include a special message when listing it. Update the application to use a menu and functions for the following: to get the genres, to list the genres, and then exit. All right. Now, your brain might tell you to start with the first task, but I'm going to tell you my brain totally does not. Because if we're going to have, this thing, where we're going to, well, I guess we are going to prompt them to enter genres first to start with. That's the first thing in the program. But from there on in, we're doing it around this like menu, right? So we have this, thing that we're always going to put on the screen, and then they're put in a selection. So we could just build the thing that does this, and I'm going to do that first. So in other words, I'm going to create the menu that I'm used to drive the program and capture the user's choice, right? And I'm also going to, since we're going to build a list of genres of music, we need a blank list. All right, so let's go back and do some preliminary work here. So first of all, let's create a new file. And let's do a save as on this. I'm not really sure why it happened like that, but maybe I was in the wrong spot or something when I did it. So we'll call this mod 3 lab 4. Storing it. So let's start with a blank list. So here we go. I'm going to make that equal to square brackets. Right. Nothing in there yet, but it's ready to go. And you know what? Maybe we should just say that here. Create a. Oh, you notice what I did here? This is a text file. I really don't know why that happened like that. Let's rename it, because you notice what's happening is because it's named incorrectly, it's not color coding, right? That's the point of an IDE that doesn't color code. Not much, basically. So create a blank list to start. Square brackets. Right. I'm going to go ahead and create that menu. So I'm going to create a menu that returns the user's choice. And then, because I'm trying to have a little bit of time efficiency here, I'm just going to drop it all in. So here's the menu. So I have a bunch of listings. So music application menu, add genres, list all genres, or end. So 3 options for the user. Then we will return the result of an input statement with this. In other words, we're going to call this from somewhere else, and then we're going to use it to drive other parts of the program. So when we say get menu option, it's going to return a number. And then based on that number, we'll probably have an if statement that will say, oh, if it's one, add the genre. If it's two, list all the genres. If it's three, just get out of there. Okay, so that's the menu. So other thing that we want to do is we want to create a couple more functions. One that will allow us to add the genres, another one that makes us list the genres, and well, we also need to prompt the user to add them in the first place. But you know what? That's part of the menu. I don't know if you guys are kind of feeling where I'm going with that. So I'm going to create those other functions. But first, I'm actually going to create this while loop way at the bottom. I'm just going to say while true. I'm just going to force it to run. I'm going to have the user enter their choice, and I'm just going to call that thing that we just created. So it's going to go up there, put the menu on the screen. They're going to type in what they're going to do. At least to begin with, we're going to start with genres first, right? And then based on their choice, we're going to steer the program. So inside the loop here, I'm going to say something like, if the choice is equivalent to 1, then we'll add genres. Now, I haven't built this yet, but I'm going to call it. So it's flagging as an error. Else if the choice is equivalent to 2, then we'll just list the genres. Also hasn't been created yet, but I will. Else, to type 3, we're out of here, right? So we're out of the loop, and the program would be done, right? And if you want, and I like to do stuff like this is, goofy stuff, but I would put in the print statement at the end, new line, and maybe say, thank you again, or, maybe that's a little snarky, maybe something like program complete. It ended. All right, so now we need to build these two functions. So what I'm going to do is let's do the add genre thing first. Okay, so I'm going to define it. Then I'm going to prompt the user to enter the genre. Oops. Copy paste epically failed. So input a genre, end to stop. So in other words, okay, well, this implies the loop once again. So I'm going to go into the loop. So I'm going to say while the user genre does not equal n in all caps. All right, so they have to type it in all caps. And right, and I could fix that how, right? If you wanted to allow lowercase, you could add dot lower here if you want. I'm not going to do that, but you can do it. So while the user is entering genres, so we're going to loop and say enter all your favorite types of music. We're going to add those. So this is where the append comes in. So I'm going to take the genres and I'm going to append whatever the user types in. We're going to add that to the end of the list. Then we're going to prompt again. So they'll keep getting prompted until we build the whole list. All right, so that's the add genres. Next, we are going to write a function that's going to list them. So let's start with just defining it. So there's the definition. Right. Now, if we're going to list them, that's actually a mechanical process. But however, we have to do a little bit of consideration here first. What if they run the program The menu comes up, nothing's in the list yet, and then they choose two to list it. Okay, well, that's kind of a problem, right? So it's got nothing to list, not very useful. So maybe we write an if statement right inside here to kind of handle that. So we're going to say if the length of genres, we can test the length of this, is greater than 0, then we're going to do stuff here. We're gonna show it, right? But we're that I, I'm just kind of building the outer structure here first. If it's not, if it, if it's empty, then we need to first add some genres first, and then you just basically transport them over to the as genres function so they can add some stuff. See how clever that is, right? So if there's nothing in there and they ask to list, well, then we'll tell them and then transport them to make them do it. Okay. But now we need to do the processing here to list the stuff that's in the genres. All right. So I'm going to go ahead and kind of like build some syntax here. And what I want to do really, you think about like how we were traversing lists, we would basically say for each, you know, thing inside of genres, we will list that music, right? And then it also had a little caveat to it, like it wanted to put in a special message. So this is kind of weird. So I'm not really sure what the message was. And let's go back to the example. You know, that's a lot of upbeats or whatever. So you could really kind of go into this, but you could, for example, um, basically pick and add a special message, maybe like one of them. You don't have to do all of them. So I'm just going to do one because I don't want to sit here all day and type this out, right? If you want to, like, if somebody chooses country and say, hey, that's my favorite, or metal, like you rock or something, or whatever, you just go for it, right? It's highly subjective, right? So I'm gonna like go back here and start building this. So if I want to do this, I'm also one other thing that you need to notice here is when we put the list back up on the screen, I think we had a directive list the genres, right? So like you would list them, but I don't know if you guys are catching this. They're adding a number in front of it, so they're numbering it as they're putting it on the screen, and they're going to put the thing on the screen and maybe a special message to go with it. Okay, so a lot to kind of wrap your head around there, but let's do this. Because I'm going to be tracking and numbering it, I normally wouldn't do this with the for loop, but I'm going to use I as a counter starting at 1. So when I number the things, I have a starting number. I'm putting that outside the for loop that I'm about to create. So I'm going to say for each G, or John, or maybe G is not a really good word, for each style in genres. So you see how that makes sense? I'm going to loop through and then I'm going to do the following. So I'm going to say if the style I'm going to do the lower conversion here because I'm just thinking that people might type upper lowercase or whatever. Maybe if style lower equals, metal, which is probably my category of choice, not probably, definitely, I will print out the following message. So I'm going to print out first, okay, we're doing an F string thing here. So inside here, I'm going to print out the I, right, the number that we're on with a dot after it and a space. Then I'm going to print out the style. Then I'm going to add my special message. I don't know. What's a special message for metal? Metal horns or like, I'm going to keep it simple. You rock. Right. So if they happen to choose metal, and then you know what, you can like you could do a bunch of these. If you want to put special messages in, that's kind of the point. So I could say else if style dot lower, oops, is country. And you know what, we can copy this print command here, and we would just change the special message, right? We could say that's so nice, or whatever. You get the point, right? So you could like preset a bunch of messages for certain styles of music. um I'm going to call that highly optional, and then this is maybe overachieving, but if it's not one of these two styles, you could put in just a simple else. So for any other style that you don't want a special message for, you can just simply print with the f string, of course, uh, the number. Oops, so that would be the I with the dot and the space, the style, and that's it. Just put the style on the screen. But with those two styles in particular, we'll have those messages. And if you want to, just for example, wanted to like do one for, let's say, jazz, right? Let's say kind of get the point. Right. Now, the other thing that we have to do inside the loop is we got to increment that I so that every time we put a new style on the screen, that the number is correct. We'll increment that inside the loop here. Oops, Control Z that. And then we just go I plus equals 1. So increment. Right. So that's all the logic for the program, folks. So let's just kind of review. Create a blank list. The menu where we grab the user's choice, or the function where we grab the user's choice and return it back to the program. The function that allows the user to add new genres to the list, the append, the listing of them with special messages if appropriate, and also an if else to catch the fact that if there's nothing in the list, that you need to add something to the list. And then finally, the while loop that does all the work of running the program, keeping it running until the user chooses 3 and pops out. And in fact, what'll happen is any value other than 1 or 2 will pop them out, right? The program. And then I have a little program complete message just to know something happened. All right, let's do a run on this. I'm going to make the console pretty big here so we can see the results. So here's our music application menu. And you know what? I'm going to test to see if I type 2 here, if it asks me to add a genre. Yeah, so you do need to add a genre first. Enter a genre and the stop. All right, so let's do metal, uh, country, uh, I don't know, disco. We've got an example of ska. They have R and B. Oh yeah, jazz. Um, uh, maybe how about bluegrass? I was going to say folk. Um, and this time I'm going to type end. So done. Now we can list them. So here's the listing. I mean, the listing could be made to look better, granted, but notice how the 3 with the special messages get their special messages in there. Everything gets numbered. It reads back the whole list to the screen. And now I'm back to the menu. So I could I could, at this point, add another style, you know, do hard rock, and then we'll end. We just want to add one more. So here we go, listing it again. So now you see that added to the end of the list. And then let's get the heck out of here. We'll press 3 and we are done. All right, so that is module 3, lab 4 in its entirety. And this video will end here. Don't forget to subscribe to the channel, folks.